Welcome to GER Hub Mathematics and Statistics lessons. Today we are going to be talking about logarithms as a topic. Okay, now logarithm, when it is taken as a topic, should actually be logarithm of numbers or logarithm of a number, but we just simply call the topic logarithm. So what we are going to be doing today would require me to specify certain things. So let me start with saying y. I'm going to write y and equate it to be the number whose logarithm we want. Okay, so I'm calling y the number whose logarithm we want. Now, when you discuss logarithms or when you deal with logarithms, you must take note of one thing, that logarithms must always be discussed in a given base. Okay, logarithms must be discussed in a given base. So I'm going to call the base in which I'm discussing logarithm of y, I'm going to call it a. So let a be the base. Okay, so the next thing is the result, which is the logarithm itself. I'm going to call it x. So I'm going to say x is the logarithm of y in base a, full stop. Now take note of one thing, as you move from taking the logarithm of y in base a to taking the logarithm of y in another base, say b, the result will be different. So when talking about logarithms, take note of one thing, that logarithms vary as the base vary. Okay, as the bases vary. Now let's see. So what I want to do is to start with a definition. Okay, definition. So what do I want to define? Based on these x, a, and y variables, or letters rather, I want to define the logarithm of y. So mathematically we define the logarithm of a number, in this case say y, the logarithm of a number, say y, in a given base, say a, is the number say x, to which one must raise the base a to give the number y. Now the definition is simple, so let's examine it. Okay, so what we call the logarithm of a number, say y, in a given base, say a, is the number x to which we can, the only number x to which we can raise the base a to give the number y. So mathematically we write that expression as logarithm of y in base a is equal to x. I'm going to call this equation 1. So mathematically we write it as the logarithm of y in base a is equal to x. I repeat, the logarithm of y in base a is equal to x. Why is the logarithm of y in base a equal to x? It is simply because x here is the only number to which you can raise a to give y. For instance, the logarithm of 25 in base 5 is equal to 2. The only reason why the logarithm of 25 in base 5 is 2 is because the only number, 2 is the only number to which you would raise 5 to get 25. That is the reason why 5 raised to power 2 is 25. Similarly, the reason why you have the logarithm of 64 in base 4 giving you 3 is because 3 is the only number to which you would raise 4 to give 64. So remember, the logarithm of a number 25 in base 5 is the number 2, simply because 2 is the only number to which you can raise 5 to give 25. The logarithm of a number 64 in base 4 is the number 3, simply because 3 is the only number to which you would raise 4 to get 64. Let's look at another example. The logarithm of 100 in base 10 is 2, simply because 2 is the only number to which you would raise 10 the base to get 100. The logarithm of the number 625 in base 25 is the number 2, because 2 is the only number you would raise 25 to give 625. That is, 25 raised to power 2 is 625, makes 2 the logarithm. 10 raised to power 2 equals 100, makes 2 the logarithm of 100 in base 10. 5 raised to power 2 gives 25, makes 2 the logarithm of 25 in base 5. 4 raised to power 3 equals 64, makes 3 the logarithm of 64 in base 4. I hope you understand that. Now, what this explanation tells us is that logarithm has a relationship with indices. So, I'm going to come over here and tell you equation 1 is called the logarithmic form. The logarithmic form of the number y in base a. Okay, so the logarithmic form of the number y in base a is this expression you have here. Okay, so what is this? This is the logarithmic form of 25 in base 5. What is this? This is the logarithmic form of the number 100 in base 10. What is this? This is the logarithmic form of the number 625 in base 25. What is this? This is the logarithmic form of the number 64 in base 4. And why is that so? I could have the logarithmic form of the number 64 in base 8, and that will give me 2. So the logarithmic form of a number varies as the base. Now, the logarithmic form of the number 64 in base 4 clearly is different from the logarithmic form of the number 64 in base 8. So the logarithmic form of a number varies as the base. Now, why am I talking about the logarithmic form of a number? I want you to know that for every logarithmic form of a number, there is a counterpart index form of that number. So let us see, how do you move from having the logarithmic form of a number to having its index form? So I'm going to bring that expression in equation 1 again here. Logarithmic form of the number y in base a equals x. Excuse me. So for you to have the logarithmic form of the number y in base a giving you x implies that a raised to power x must have given you y. So this is the logarithmic form of the number y in base a, and this is its counterpart index form. Okay, so this is the index form of the number y in the base a, and this is the logarithmic form of y in the base a. So you can quickly see that the logarithmic form of 25 in base 5 equals 2 implies that there is a corresponding index form of the number y in base 5, and that will give you 5 raised to power 2 equals 25. Okay, so we can do that also for the logarithmic form of 64 in base 4. That will give you 3, and that implies the index form of that number 64 in base 4 will be 4 raised to power 3 equals 64. So if you do that again for log 64 in base 8, which is the logarithmic form of 64 in base 8, which gave us 2, that would imply there is an index form of 64 in base 8, which will now be 8 raised to power 2 equals 64. If you do that for the logarithmic form of the number 100 in base 10, which gave us 2, you would see that there is a corresponding index form of that number 100, and that in this case it will be 10 raised to power 2 gives 100. Okay, now I could do that again for the number 625. So the logarithmic form of 625 in base 25 was 2, and that implies that there is a corresponding index form of 625 in base 25, which means 25 raised to power 2 is equal to 625. So what have we just done? We have been able to show you that for every logarithmic form of a number, there is a corresponding index form of that number. Okay? Now let us take more examples on that. I'm going to call it converting logarithmic forms of numbers to index forms of numbers. Okay, so if I give you the logarithmic form of a number, you should be able to convert it to its corresponding index form. So let's see, the logarithm of a number 49 in base 7 was given to you, and that means log 49 in base 7 is equal to 2. Remember, the logarithm of 49 in base 7 is only equal to 2 simply because 7 raised to power 2 will give you 49, and that means that the corresponding index form of 49 in base 7 will be 7 raised to power 2 equals 49. So this is the index form, this is the logarithmic form. Now let's go over again to a number 4 in base 2. The logarithm of 4 in base 2 is 2. Again, that is because 2 raised to power 2 is equal to 4. So 2 raised to power 2 equals 4 is the index form corresponding to this logarithmic form. Now, the logarithm of 1000 in base 10 is equal to 3. This is the logarithmic form of 1000 in base 10, and it is equal to 3. This is because 10 raised to power 3 is equal to 1000. So this is the corresponding index form to this logarithmic form. Okay, then let's take one more example. The logarithmic form of a number, say 125 in base 5 will be equal to 3, and that is because 5 raised to power 3 should give you 125. So this is the logarithmic form, this is the index form. So it is very simple to convert numbers from their logarithmic forms to their corresponding index forms. Okay? Now, what if we were to convert numbers in index forms to their logarithmic forms? What if we were to convert numbers, that is converting numbers in index form to their logarithmic forms? What if we were to do that? If I gave you the number 7 raised to power 2 equals 49, being the index form of 49 in base 7, the corresponding logarithmic form will be the logarithm of 49 in base 7 is equal to 2. So in this case, this is the index form, and I'm moving back to the logarithmic form. If I gave you the index form of 25 as 5 raised to power 2, you should be able to explain that that is only because there is a corresponding logarithmic form, log 25 in base 5 equals 2. And this is simply because of our definition of logarithm, that the logarithm of a number, in a given base is equal to another number, only because that number it is equal to is the only number to which that base will be raised to get the number whose logarithm we seek. So, that being said, let us now go to what I'm going to call types of logarithm. Okay? Types of logarithm. That is the next thing I want to discuss in this video. Types of logarithm. So let's see. Now, for types of logarithm, I'm going to tell you few things. Types of logarithms. So what am I going to be saying here? The first thing I want you to know or take note of is that logarithm, the type of logarithms depends on the nature of the base. Okay? The type of logarithm you are dealing with, be it at university or university level or college level or secondary level, the type of logarithm you are dealing with is only because of the type of base. So logarithms have their types, and their types are dependent on the base. So let's see, for that reason, there are three types of base I'm going to categorize the logarithm of numbers into. Okay? So there are three types of logarithm. That's what I'm trying to say. There are three types of logarithm. The first type of logarithm is called common logarithm. The second type of logarithm is called Neperian logarithm. I'm going to explain these. Also called natural logarithms. So this is the second type of logarithms. The third type of logarithm is called theory of logarithms. Now I'm going to explain the difference between these three. Now, let's start with common logarithms. So what are we saying? There are three types or categories of logarithms you will be dealing with. One is the logarithm of numbers, called common logarithms. The other is called natural logarithms, also called Neperian logarithms. The third one is called the theory of logarithms. Okay? So let's start with the first one, common logarithms. So what are common logarithms? Common logarithms are logarithms of numbers taken in base 10. So the logarithm of any number in base 10 is called the common logarithm of that number. I repeat, the logarithm of any number in base 10 is called the common logarithm of that number. Okay? So if I seek the logarithm of 100 in base 10, which in this case gives me 2, this logarithm I have just obtained is called the common logarithm of 100. Take note, you don't say the common logarithm of 100 in base 10, because once you mention the word common logarithm, it means you are taking the logarithm of that number in base 10. So if I am to read this, I would simply read it as the logarithm of 100, the common logarithm of 100. So alternatively, I can say the logarithm of 100 in base 10, but not the common logarithm of 100 in base 10. So simply say common logarithm of 100, which means 2. And in this case, telling us that we are taking the logarithm of 100 in base 10. Okay? So don't say common logarithm of 100 in base 10. Simply say logarithm of 100 in base 10 or the common logarithm of 100. Now, this was an easy task to do. However, if we were to take the logarithm of 25 in base 10, it won't be as easy as this. Remember, this was simple because we quickly can find the number 2 to which 10 must be raised to give 100, even without any complex calculation or involvement. But looking at the logarithm of 25 in base 10, it is not as easy as that to obtain what the logarithm will be using this same technique. 10 raised to power what gives 25. So if there is a number x to which 10 can be raised to give 25, that x will be called the common logarithm of 25 in base 10. So how do we obtain common logarithms for reasons such as this? We obtain common logarithms using what is called a log table, a logarithm table. So logarithm tables are used. Logarithm tables or log tables are used to obtain common logarithms. So if you want to obtain common logarithms, you simply use logarithm tables. Okay? So I'm going to be discussing common logarithm in another video. Okay? So let's move to the next type of logarithm. So what did we say about common logarithms? We have just said that common logarithms are logarithms of numbers in base 10. Now let's move again. Another thing we said about common logarithms is that common logarithms of numbers are, apart from the fact that they are obtained in base 10, they can be obtained using what we call log tables, logarithm tables. Okay? So the next thing I want to do is to move over to the next type of logarithm. And the next type of logarithm is called natural logarithm. Natural logarithm. Okay? So another name for natural logarithms is Neperian logarithms. Neperian logarithms. Full stop. Now, this is because it is named after John Napier. So, John Napier happens to be the inventor of this type of logarithm. And I'm going to explain why. This type of logarithm. So, it is named after John Napier. Okay? Now, having said that briefly about natural logarithm, that number one, it is also called Neperian logarithm, and this is because it is named after John Napier, the inventor of this type of logarithm. Let us now look at what natural logarithms are. So, I'm going to start with telling you that there is a number e called the exponential. There's a number e called the exponential. The exponential is a type of irrational number. So the exponential is a type of irrational number, and the exponential is approximately equal to 2.718 ... Okay? It's approximately equal to 2.718, and it is a constant. Okay? So, when you take the logarithm of a number, if you take the logarithm of a number y in this base e to get a number x, this base gives this type of logarithm a name called the natural logarithm of y. So when you take the number y in a base e, which is the exponential, you are no more looking for just any type of logarithm. You are looking specifically at obtaining what is called the natural logarithm of y. Okay? So if the answer to taking the natural logarithm of y is x, then we say the natural logarithm of y in base e, which is the natural logarithm of y rather, is equal to x, meaning that the logarithm of y to the exponential as its base will give you x. Okay? So you don't say the natural logarithm of y in base e. You rather say the natural logarithm of y, because that implies you are taking the logarithm of y in base e. So once you say you are taking the natural logarithm of a number, everyone should know that you are taking the logarithm of that number in base e. So we often write this as ln e or ln y equals x. This is pronounced as ln. Ln is pronounced as ln. Okay, so the ln there stands for the logarithm to base e. So we often do not write it in this form, log y to base e equals x. We often write it as ln y equals x, where this ln is read as ln. So if I'm to read this, it will be ln y equals x. And ln y equals x simply means I am taking the logarithm, the natural logarithm of y. And that natural logarithm of y is x. So let's see how we read this. Log 25 to base e equals x is equivalent to writing ln 25 equals x. Log 100 in base e equals x is equivalent to writing ln 100 equals x. Log 50 in base e equals x is equivalent to writing ln 50 equals x. So what am I doing? I am simply saying that ln, which is pronounced as ln, is used to represent log e. So once you see ln 25, which is read as ln 25, it means you have to take the logarithm of 25 in the exponential as its base. So remember what I said earlier, the type of logarithm you are dealing with is dependent on the type of base. So when the base is e, otherwise known as the exponential, which is a constant approximately equal to 2.718, then what you are doing is taking the logarithm or the natural logarithm of that number. Remember, the natural logarithm of a number is also called the Neperian logarithm. And Neperian logarithm comes from the fact that it is named after the inventor, John Napier. Okay? So, let's move now to the third type of logarithm. Let's move to the third type of logarithm. So the third type of logarithm is called theory of logarithm. So it is actually not a type of logarithm, but just a category of logarithms. So logarithms are categorized into 3 groups, and those 3 groups are dependent on the type of base. So now we have talked about common logarithm, which is taking the logarithm of number in base 10. We have talked about Neperian logarithm, which is you taking the logarithm of numbers in base e, and e happens to be the exponential. What if we want to consider taking the logarithm of numbers in any other base apart from e and 10? So that will give us what is called theory of logarithms. Theory of logarithms. So under the theory of logarithms, we dedicate our efforts to obtaining the logarithm of numbers in bases other than 10 or e. So theory of logarithms describe the logarithms of numbers in bases other than 10 or e, full stop. So when you seek the logarithm of a number in a base that is not 10 and that is not e, then you are taking the theory of logarithm. You are dealing with theory of logarithm. So what that means is that discussing numbers like this, discussing the logarithm of 25 in base 7 should be treated under theory of logarithms. Discussing the logarithm of 100 in base 8 should be treated under theory of logarithms. Discussing the logarithm of a number like 54 in base 6 should be discussed under theory of logarithms. Why? This is not equal to 10 and it is not equal to e, the base. This base is not equal to 10 and it is also not equal to e. This base is not equal to 10 and it is not equal to e. So when you describe the logarithm of a number in a base other than 10 or e, the exponential, then you are discussing the theory of logarithms. Okay? Now, let us look at the rules of logarithms. Now, in this video, I'm going to mention the rules of logarithms. But the next video on logarithm would dedicate efforts to proving the laws of logarithm, and then we shall be discussing something else like solving logarithmic equations and indicial equations. Okay, so let us see what are the laws of logarithm. Laws of logarithms. Laws of logarithms. Law number 1 is this law. The logarithm of a number m in base a plus the logarithm of another number n in base a is equal to the logarithm of the product of m and n in base a. Okay? So when you add the logarithm of one number in a given base to the logarithm of another number in that same base, then it is equal to taking the logarithm of the product of those numbers in that same base. So this law is called the addition law of logarithms. So the law may be called the addition law of logarithm. Number 2, the second law. Take note of these laws because we are going to be proving them in my next video on logarithm. Okay? So law number 2 is this law. Taking the log of a number m in a given base, say a, and subtracting from the result the logarithm of a number n in the same base will give you the result log m over n in that base a. So I repeat, taking the logarithm of a number m in a given base and subtracting from the result of this the logarithm of another number n in that same base will give you the logarithm of their quotient in that base. Number 3, the logarithm of, okay, so the law number 2 is called the subtraction law of logarithms. The subtraction law of logarithms. Okay? So, the next law is this. This law describes a situation as this. When you take the logarithm of a number m in a base that is equal to the m itself, that is log mm, your result will be 1. So the logarithm of a number in a base equal to that number is 1. I'm going to call this law the law of identity. The law of identity. Okay? Now, that brings me to law number 4. So, when you take the logarithm, for law number 4, when you take the logarithm of a number 1, if you take the logarithm of 1 to a base a, the result will give you 0. Okay? So, I'm going to call this the zero law of logarithm. The zero law of logarithm. Now, take note, I'm calling these laws by these names. Does not mean that in some other textbook you read or some other online source, you will find them written under these names. So do not know the logarithms, the laws of logarithms by the names they are called. Rather know them by what they are. Okay? know them by what they are, not the names they are called. So whereas I'm calling it the zero law, it may be called something else as described by another author, okay, or by another teacher. So this is called the zero law. It tells you that when you take the logarithm of 1 in any base, it gives you 0. Now, let's go to law number 5. For law number 5, let's see. So for law number 5, I'm going to take this law. The logarithm of a number m raised to another base is equal to b, the power of the number whose logarithm we seek, multiplying the logarithm of that number in base a. So I'm going to call this law power of logarithm law, or just power law. Okay, so it tells you that when you seek the logarithm of a number, say m, that is already raised to a power, then the result will be that power multiplied by the logarithm of m in that base. Again, when you seek the logarithm of a number having a power, the result you would get will be the power multiplying the logarithm of that number in the base. So that is called the power law. Now, take note, in this law, you will notice that the power b belongs to the number whose logarithm we sought. The next law is the law I'm going to write as this. So what happens if the number whose logarithm we seek is not the one carrying the power? Rather, it is the base itself that is carrying that power. The result will give you 1 over b logarithm m to base a. So when it happens that the number whose logarithm you seek is not the one carrying the power b, but it is now the base carrying the power b, then the result will be 1 over the power the base carries multiplying the logarithm of the number in that base a. So this law is called power of base law. Power of base. Okay? Now, that brings me to law number 7. So we are going to be proving some of these laws, probably not all of them, but we are going to be proving some of these laws in my next video. So let's see the next law. The next law is this. Sometimes there are certain problems in logarithms, as we are going to see when we go into our solver series on logarithms, that will require that we change the base. So there is an accommodation in the laws of logarithm for what is called the change of base. If a particular problem can be simplified by changing the base of the logarithm, then you have to do so. So if we are given log m to base a, and simplifying a particular problem would require me to change the base to b, the result will be log of m to base b over log of the former base a to base b. So this law is called change of base, the law of change of base. Okay? It tells you that it is possible to change the logarithm, the base of a particular logarithm to a new base. And for you to do that, it will take you taking the ratio of the logarithm of that number in the new base to that of the logarithm of the former base in the new base. So it is called the logarithm of change of base. Now, or the law of change of base rather. Now, if it happens that I can actually write this logarithm of m in base a, it is possible to write this as 1 over logarithm of a in base b. Okay? We are going to prove this law. logarithm of m in base a equals 1 over logarithm of a in base b, in base m rather, in base m. Okay, so, and that brings me to another law, law number 9. It is also possible to write this as log m to a equals log m to a over 1. This I am not going to actually put as a law, but I'm going to explain why, because it comes from this and this gives birth to this. Okay, so these are the laws of logarithms we are going to be discussing in my next video, where I'll be showing you how to prove them and how to solve problems on logarithms. Okay, so we are going to be solving problems on logarithms in my next video, but in this video my interest was to teach the student how to tackle the laws of logarithms, how to understand logarithm for what it is, and how to also know the different types of logarithms and why they are so, how to convert logarithms in a particular logarithmic form to index forms, their corresponding index forms. So please like this video, watch this video. I would suggest you really watch this video because it will make you learn so much. And I would suggest, most importantly, you please subscribe to the channel. Your subscriptions will take us very far. It will encourage us to make more videos and more content. Thank you very much and have a nice day.